This video is on the division properties of exponents. First property we're going to take a look at is called the quotient of powers. So to divide two powers that have the same base, we want to subtract their exponents. So the rule says a to the power of m divided by a to the power of n is equal to a raised to the power of m minus n. For example, x to the sixth power divided by x squared is x to the 6 minus 2 power, or x to the fourth. So why is that true? Why does that work? X to the sixth is x times x times x times x times x times x. X squared is x over x. So when we divide those, this x cancels with that one, that x cancels with that one, and so we're left with x times x times x times x, which is x to the fourth. Let's take a look at an example here. We need to simplify a to the fifth, b to the fourth over a times b squared. So we could think of this as a to the fifth over a times b to the fourth over b squared. And let's go ahead and use the subtraction rule. Remember, this is a to the 1. That's equal to a to the 5 minus 1 times b to the 4 minus 2. Since I'm dividing, I'm subtracting my exponents, or a to the fourth b squared. Next rule we want to take a look at is called the power of a quotient. So if we have a quotient, if we have two things being divided and we're raising that to a power, that's going to be the same thing as the numerator being raised to that power and then the denominator being raised to that power. So if a divided by b is all raised to the power of m, that's the same as a to the m divided by b to the m. So for example, 2/5 to the third power is the same as 2 to the third power over 5 to the third power. 2 to the third power is 8, 5 to the third power is 125, so that would simplify to 8 over 125. Why is that true? Because 2/5 to the third power is 2/5 times 2/5 times 2/5. 2 times 2 times 2 is 2 to the third. 5 times 5 times 5 is 5 to the third. That's why that works. So let's take a look at an example of this. Here we have to simplify 2x squared y over 3, all raised to the third power. So that means that each part of that is going to be raised to the third power. That's the same as 2x squared y to the third power over 3 to the third power. So as we saw in the previous video, 2x squared y is going to be 2 to the third power, which is 8, x squared to the third power, which is going to be x to the 2 times 3, or x to the sixth, and then y to the third power over 27. So that exponent applies to each part, both the numerator and the denominator there. Next property is called the zero exponent property. Any non-zero base raised to the power of 0 is equal to 1. So the rule is a raised to the 0 power equals 1. For example, 7 to the 0 equals 1. Why is that true? Well, if we had something like x to the fifth over x to the fifth, that would be x to the 5 minus 5, or x to the 0. Well, x to the fifth over x to the fifth, using these, we know that that's equal to 1 because you have the same thing on the top and the bottom. So anything raised to the 0 power is going to be equal to 1. So here's our example. 3a squared b to the fourth divided by 6ab, whole thing raised to the 0 power. Since the whole thing is raised to the 0 power, that's just equal to 1. One of my favorite properties. And the last property we're going to take a look at here is called the negative exponent property. A base raised to a negative power is equal to the reciprocal of the base raised to a positive power. Okay, that's a little confusing. Let's take a look at the rules. So a raised to the power of a negative n is equal to 1 over a to the positive n, and 1 over a to the negative n is equal to a to the positive n. So for example, x to the negative fifth is 1 over x to the positive fifth. We can make that exponent positive if we put it in the denominator, and 1 over x to the negative fourth is x to the positive fourth. That negative exponent, if we move it to the numerator, we can make it positive. Why is that true? Because x squared over x to the fifth, we would subtract that. That would be x to the 2 minus 5, or x to the negative 3. Okay, another way of thinking of that is x squared over x to the 5th is x times x over x times x times x times x times x, which is 1 over x to the 3rd. So x to the negative 3 is equal to 1 over x. X to the negative 3 is equal to 1 over x to the positive 3rd. Let's take a look at an example here. So here we have 5 r to the negative 3 t to the 4th divided by negative 20 r squared t to the 7th u to the negative 5th. A lot going on there. I'm going to treat this as 4 different problems. I'm going to treat this as 5 over negative 20, deal with my coefficients, times r to the negative 3 over r squared, times t to the 4th over t to the 7th, times 1 over u to the negative 5th. And let's deal with each part of that. So 5 over negative 20 simplifies to a negative 1/4. And here I'm going to use my subtraction property. So I have r to the negative 3rd minus 2. If I'm dividing the same powers, I can subtract the exponents. I'll come back to that in a minute. Same thing here. That's going to be t to the 4 minus 7. And for this one, probably the easiest way is just to remember the rule and make that a u to the positive 5th. Put it in the numerator. Notice that when I use the subtraction on the exponents here, I don't have a denominator. It's basically like everything's going on in the numerator right now. So that's going to turn into a negative 1/4 r to the negative 5th t to the negative 3rd u to the 5th. Now I need to take anything that's a negative exponent, any power that's raised to a negative exponent, make that exponent positive, put it in the denominator. So what am I going to have here? I'm going to put my negative out front. I've already got a 4 in the denominator for my 1/4. That's going to give me an r to the positive 5th in the denominator, t to the positive 3rd in the denominator, and this one is positive, so that stays u to the 5th on top. So how do we know when a rational expression like this is simplified? An expression is simplified, or actually any exponential expression, is simplified if each base appears only once. Your answer is only going to have one a, one b, or one x, or one y. There are no powers of powers. There's no parentheses. There's nothing being raised to a power other than just the base. All of the fractions are simplified. So for example, in the previous one, I had to simplify 5 over negative 20 to a negative 1/4. And there are no negative exponents. So I took my r to the negative 5th and made that an r to the positive 5th in the denominator. So here are a couple practice problems I'd like you to try on your own. Go ahead and stop the video, do these in your notebook, and we'll come back and check in just a moment. Okay, let's take a look at each one of these. Simplify each expression. Here we have k to the 7th, m to the 10th, p times p over k to the 5th, m to the 3rd times p. So I'm going to use the subtraction property. So this is going to give me k to the 7 minus 5 times m to the 10 minus 3. And I could think of this as I could think of those as p to the 1 times p to the 1 minus 1. That's going to give me k squared, m to the 7th, p to the 0, which I know is equal to 1. So I have a final answer of k squared, m to the 7th. Here I have 2y squared over 3z to the 3rd, the whole thing squared. So that's going to be the numerator squared, which is going to give me 4y to the 4th, over the denominator squared. 3 squared is 9. Z cubed squared is z to the 6th. My fraction can't be reduced, and each base appears only once, so I am simplified. Number 3, I'm not going to read all of that because I noticed that whole nasty looking expression inside the parentheses is raised to the 0 power. I know that that's equal to 1. And our last one, 32 a to the negative 8th, b to the 3rd, c to the negative 4th, divided by negative 4 a to the 3rd, b to the 5th, c to the negative 2. Simplify that. I'm going to rewrite that as 4 different problems. So 32 over negative 4 times a to the negative 8th over a to the 3rd times b to the 3rd over b to the 5th times c to the negative 4th over c to the negative 2. And I'm going to start by simplifying my fraction. 32 divided by negative 4 is negative 8. I'm going to use the subtraction property on the rest of these. So a to the negative 8 minus 3 times b to the 3 minus 5 times c to the negative 4 minus negative 2. Be careful, it's not negative 4 minus 2. It's negative 4 minus a negative 2. So that's going to give me negative 8 times a to the negative 11th times b to the negative 2 times c to the negative 2. So my negative 8 is fine, but each of these is a negative exponent, so I can make that exponent positive if I move the whole power into the denominator. So I'm going to have a negative 8 on top, a to the 11th, b squared, c squared. So in this video, we took a look at some of the division properties of exponents, how to deal with dividing two powers, how to deal with negative exponents, and how to deal with raising a quotient or a fraction to a power.